Hello, this is Oded Hadas from Traceman Communications, and in this video, I will talk about PON security, specifically relating to the physical layer aspects of PON. So let's start with an introduction so we all understand what this video is about. So this presentation or this video describes the main security risks in PON networks that are related specifically with the physical layer, also known as the ODN. And we have some other video clips that you can find on our channel that deal with the mechanisms that the PON standards, the PON technologies define for handling security risks. But one of the questions that some customers came back to us and asked is, okay, so there are some mechanisms in the protocol, but what about the physical media itself? Is the PON itself, the fiber, the splitters, the connectors, is it secure? Or what are the security risks and how are they handled? So this is exactly the answer this is what we will answer, the question we will answer in this video. It is relevant for all the PON technologies, ranging from GPON up to the 25G SPON, and also the future PON technologies like 50G HSPON, 100 PON, which is more futuristic, and so on. So let's start with the basics of fiber media. So inherently, a fiber-based network is more secure than any other communications network for various reasons. First of all, fiber doesn't have any electromagnetic radiations, unlike, for example, copper or wireless. It isn't subject to electromagnetic interference, and it is much more difficult to tap than other media. So inherently, it's more secure. And since fiber is the media in PON, let's look at the structure of PON and refresh our minds with the transmission basics. So, and again, this is something we presented in other video clips, which you're welcome to watch. So in the downstream, the transmission is point to multipoint. Everything that the OLT transmits, all the ONUs receive. And then it's up to the ONU to decide which of the packets that it receives are relevant for it and which it should ignore. However, this creates a security risk, because if someone can reprogram the ONU or develop something that looks like an ONU and sniffs the PON, this hacker can see all the packets, all the communications downstream of all the customers. So this is handled by AES encryption, where the keys that are used for encryption for each ONU are generated by the ONU itself and sent to the OLT on the PON. And the other ONUs don't get them. And there's some assumption behind this about how transmission works on the PON. The assumption is that whatever an ONU transmits, only the OLT can see, and the other ONUs cannot. And then when we talk about the upstream, in the upstream, different ONUs transmit to the OLT. They do not transmit to each other. Again, as shown in this diagram. There's a TDMA mechanism in which the OLT assigns time slots in PON and GPON, XGS-PON, that are called BW maps. In EPON, they're called grants, but similar concept. In any case, each one transmits to the OLT and they don't transmit to each other. And the assumption behind these transmission basics is that if you have multiple customers on the PON, if one customer transmits to the OLT, other customers cannot get this transmission. Call them Tom and Harry, so whatever Harry sends, Tom cannot receive. And this is exactly the point we want to explore. Why, or under what is the basis for making this assumption? So let's look at the PON splitter. The PON splitter has one input, which is the side connected to the OLT, and a number of outputs, which are connected to additional splitters or directly to the ONUs. They are called outputs, but they are actually bidirectional. Data can also go in, or transmission can go in from the outputs to the input. Now, the fact is that in a PON splitter, when light is injected into one of the output ports, some of this light propagates back through the other output ports. Okay, there's not 100% isolation. This transmitted light will go to the other customers. In other words, whatever the ONU transmits does reflect in some way to the other ONUs. And there's a factor called directivity, a factor of the splitter, which is defined as the fraction of power transferred from one output port to another output port. If you want to learn more about this term and beyond, there is a link down here where you can learn about it. So, is splitter directivity a security risk? In other words, the fact that, okay, one output gets transmission from other outputs, is this a security risk? So to determine this, let's look at the ONU transceiver specifications. Now, these are transceivers that are used in the ONU, but they are, if someone were to design some other equipment which is intended for tapping the network, they would still need to use the same transceivers because this is what's available in the market. So the ONU transmitter receiver for GPON is defined by the standard ITU-T G984.2, and the mean launched output power of the ONU has a maximum value of plus 7 dBm. The sensitivity, which is the minimum power that it can receive, is minus 28 dBm. And if we take XGS PON, the standard here is G9807.1 XGS PON, ITU, of course, ITU-T. Here, the transmitted power is a little bit more, 2 dB more, plus 9 dBm. And the minimum sensitivity is, again, minus 28. So the maximum directivity, which creates a risk of allowing one ONU to receive the transmissions of another ONU through the splitter, is calculated as the transmitter mean launch power minus the receiver minimum sensitivity. And if we take the worst of the two, the worst case of the two, which is XGS PON, we end up with plus 9 minus 28, which is plus 37 dB. Now, the PON splitters in the market typically have directivity of over 50 dB, meaning that this risk is far from being realistic. Means there's a 13 dB margin between the required or the chance, the theoretical chance to get the transmission of another ONU and what can actually happen. So this is a very large margin. And if we take the data sheet of a typical splitter, this is, again, I will not disclose the brand, but this is just a typical one. It has different versions, 1 to 2, 1 to 4, up to 1 to 64. And in all of them, the directivity is guaranteed to be 55 dB. So it's another 5 dB above the typical minimum of 50 dB. So the margin is significantly more than you need, and there's really nothing to worry about. And the bottom line is that this is not a security risk. So thank you for watching this video. If you want to learn more about PON technology, you're welcome to go to our website and watch our webinars. We have an extensive list of webinars on various subjects related to PON. The link is written here. I will also include it in the description of this video. You're welcome to visit Tracepan and learn more about our company, or to contact us at info@tracepan.com. If you like this video, give us a like, and you're also welcome to subscribe to our channel. Thank you for watching. I'm Oded Hadas, and see you in the next video.